Okay, here is the video for our polynomials notes. We're going to start by filling in some blanks, talking about the zeros of a function. We have different words for the zeros of a polynomial. We might use this word, roots, or x-intercepts, or solutions. And if you're looking at a graph, these are where the graph crosses the x-axis. Those are the roots or the x-intercepts or solutions, or sometimes we call them zeros because at these x values, the y value is 0. Each zero also has a multiplicity. This tells you how many roots are at the 0. So when we have, for example, a quadratic, right here, maybe this x value is 2, but we know that from this bounce behavior that we actually had 2 factors that, when solved, would give us that 0. So the 0 itself of 2 is just one number, but its multiplicity is 2 because its factor occurred twice, and it creates this bounce behavior in the graph. So for example here, if I was factoring this function, it factors to x minus 3 times x minus 3. This means I have a 0 at x equals 3. So my root is 3, but the multiplicity is 2. So what we're going to be doing today is, given zeros, write the function in factored form and then multiply the factors out to standard form. We're going to be doing that in these problems where we're not given any graphs, just the roots and their multiplicities. And then on this last problem, we're going to find the root and their multiplicities from the graph, write the factored form of the equation, and solve for the a value. So those are our goals for today. All right. So I'm going to follow these steps and explain them as I go while I work the example problems. So the first step, write each root as its corresponding factor. So if I have x equals a, some number a, as a solution or 0, I know its factored form was x minus a. Just like this was a 0 right here, x equals 3, that comes from the factored form x minus 3. Or here, x equals 2 was the 0, x minus 2 was the factor that gave us that 0. Because remember, in factored form, we set that equal to 0 and solve it. That's our zero product property. All right. So first step, write each root as its corresponding factor. Step 2, write out all of the factors with the leading coefficient a in front. And then step 3, multiply the roots out. And then this sentence right here, the simplest equation, has a leading coefficient of 1. And you'll see in this first example, it says write the simplest one. So here we're going to have an a value of 1 for this example. So I'm given 2 solutions, -1 and 4. If -1 is a solution, that means its factored form was x plus 1. And if 4 is a solution, then its factored form was x minus 4. So step 1, write each root as its corresponding factor. And then write out all the factors with a leading coefficient of a in front, so I have that. And then multiply the roots out. So, or it should, I think that should probably say factors, but that means foiling this situation or thinking of it as a repeated distributive property. Take this first term x and distribute it there. That gives me x squared and -4x. And then take the second term in that first binomial, the 1, and distribute it. So positive 1x and negative 4. And the a is going to be 1, so I'm not going to bring that down because if you multiply by 1, it doesn't change anything. So now I'm just going to combine my like terms. And there is my quadratic. The difference between this problem and the next one is that I have an additional 0 here. So I'm going to set the problem up the same. These are the corresponding factored forms for those zeros, x plus 3, x minus 2, x minus 5. I'm going to set up my equation in factored form. And this time what I'm going to do is multiply the first two binomials together. I'm going to go ahead and replace a with 1 and then just not bring it down. Distribute the x, that gives me x squared minus 2x. Now distribute the 3, that gives me 3x minus 6. So I've multiplied those first two binomials together. Now I bring down this last binomial and multiply it. And there are different ways you can do this. You can do box method if you like. You can do repeated distributive property. So for example, you can take this x squared, distribute it to the x, distribute it to the negative 5. You can take this x, distribute it to the x and negative 5, and then you can take the negative 6 and distribute it. I like to do distributive property backwards with the smaller polynomial group. So I like to take this x and distribute it here. And then I'll take the negative 5 and distribute it. And then I like to line up my like terms. And then combine. On this next problem, we're given some zeros with their multiplicities. The formatting is kind of hard, but this is one section here. I have a 0 of negative 2 with a multiplicity of 1. In this next section, I have a 0 of 1 with a multiplicity of 2. And on this last section, I have 4 as a 0 with a multiplicity of 1. I'm not going to do the a equals 1 this time. I'm just going to drop that off for now. So I took the opposite signs in my factor. So I have x plus 2, x minus 1, x minus 4, and the multiplicities are the exponents on my factor. So multiplicity of 1, of 2, and then of 1. So remember that squared means times itself, so I'll have x minus 1 times x minus 1. And then since we're multiplying 4 things here, what I like to do is multiply these two together using FOIL, these two together using FOIL, I'm going straight to the answer. I'm skipping the middle step here. And then you can do box method here, or you can do repeated distributive property. You can take this first term x squared and distribute it to all three of these things. Then take the middle term x and distribute it to all three of them. And then take the negative 2 and distribute it to all three. And then you would combine like terms. So I want you to pause your video and do that math and then come back and check my work with yours. Okay, so I did repeated distributive. I took the first term x squared and multiplied it by everything in the second group and got this first row. Then I took the middle term positive x and distribute it to everything in the second group, and I got this middle row. And then I took negative 2 and distributed to everything there and got the third row. And you'll notice that I lined up my like terms as I was doing my distributive. And then I got this final answer. X to the 4 minus 4x cubed minus 3x squared plus 14x minus 8. And then on the back of this page, these first two sections, I'm going to skip over all the words and just tell you the major point. This section is saying if you have a bounce behavior at a root or 0, where it bounces off the x-axis and goes in the opposite direction. So this is at 1, 2, 3, 4. This is at x equals 5. Its factored form would be x minus 5, and it would have an even multiplicity, and so we would give it a minimum of a 2 exponent. And then for this section, if it has this hang behavior right here, looks kind of like an x cubed. So that looks like it's at negative 1. Then its factored form would be x plus 1, and we would give it a minimum multiplicity of 3. So it's going to be odd and at least 3. Okay, and then we know when it crosses straight through, like right here. So that's at 1, 2, 3, 4, 5. X equals negative 5. Its factored form is x plus 5, and it has a single multiplicity, so it will have an exponent of 1. So we're going to use that information down here. We are going to figure out the root information for ourselves, what its multiplicity is. We're going to write our factored form with the a value, and then we're going to solve for the a value. So I want you to pause your video, find the x values, write those roots here, write their factored form below with an a as a placeholder, and then come back to the video and we'll talk about how to solve for a. Okay, so here are the roots. I've already made a note that they all have a multiplicity of 1 because they all cross straight through. I set up my factored form with my a value, holding the place. And then here's how we're going to figure out what a is. This point has been marked on the graph. That is at 2, 6. That represents an x and y value that would satisfy my equation. So I'm going to plug those in everywhere I see an x and for this y. So 6 goes in for the y, and 2 goes in for all the x's. Now, order of operations says we just simplify all the parentheses next. And then I'm going to multiply 5, 10, negative 3, negative 5. That is 10 times 15. Positive, so it'll be 150. Divide by 150. Simplifying the fraction, you can divide 6 out of both of those, and that's going to give me a is 1 over 25. So I take that value back into this general form equation and plug it in for a, and we can leave this in factored form. The directions say factored form, and we all said thank you, because that would be annoying to multiply all that out. You can leave the x minus 0 factor like that, or just as x. And we are done.